Hi everyone. I'm sure you're all absolutely exhausted, but this will be the last one, so it'll be fun. So what I'm going to be talking about is an introduction to Google TV, because obviously a lot of people, this is kind of the first time they're kind of getting the opportunity to develop for Google TV. So yep, going to give you a brief introduction and then go over some of the Anymote Protocol, which is a second screen experience that you can create. So the first question is, what is Google TV? And ultimately, the main aim of Google TV is to be the open platform. At the moment, there's a lot of smart TV platforms out there. Each OEM seems to be going with their own direction and what they want to do. And as a result, a lot of developers are sort of coming to us and saying, look, I developed this app. It works on one TV. I've tried it on another TV on the same platform. It doesn't work. I spend a little bit of time trying to make it work on both TVs. It's all good. Then they push out a firmware update. I get no warning of it. It breaks the app, and I've got to start all over again. And the whole point of Google TV is to be that platform where OEMs can take it, use it in their TVs exactly like they can with mobile phones and tablets and Android, and then that way developers, you've got access to one platform that you have to target. So obviously we have something that's awesome at doing this, Android. At the moment running Honeycomb 3.2, and one of the other DevRel team have kind of always included this image in their slide deck. It's because he built these, so yeah, whenever we say it's Android, this is the slide that I always like to pull out. But obviously, we've made some changes to Android, so we obviously changed the UI so it fits better on a TV, it makes more sense. But we've also added additional hardware restrictions that we need manufacturers to stick to, because we have HDMI pass-through, which means that we can take content from other sources and pipe it through to the TV. So we've put in hardware restrictions to ensure that that content is protected, so that way content providers are satisfied that their stuff is going to be safe. But we've also added additional codecs to the platform, because at the end of the day, this is a multimedia device. People want to stream content. If we can't play that content, that's not so good. So there's additional changes there. So we've launched in the US, UK, France, Germany, Netherlands, Brazil, Mexico, Canada. So the Sony box is the first one that's gone international, which is great. But this isn't the only box. So over in the US, they've recently had the Vizio and the LG launched a couple of months ago. And I always include this because it's interesting to see what manufacturers are doing in terms of the remote, the hardware. So here you can see Vizio, they've got custom buttons for specific apps. LG, they've gone and put Google TV in the actual TV set itself. And we've got other partners coming. So Samsung, yeah, they launched a TV. They announced it at IFA, sorry. And then Hisense are also launching their TV in a couple of months, I believe. So yeah, we're getting more and more of these boxes being released into the market. And plus, we recently announced the native Play Store. And I include this just purely because it means that subscription billing and in-app billing is now supported on Google TV, which it wasn't until fairly recently, which is always really important, because the minute you start looking at TV, one of the main use cases is streaming content and providing content, and subscription billing is kind of quite a core kind of business model for that sort of thing. So as a developer, you might be saying, well, why do I care? What's this got to do with me? Why would I want to develop for Google TV? And when you start looking at statistics about various things around this kind of area, it's getting to the point where there's actually more TVs in a house than people, which is ridiculous. But because of this, people are spending about 5 hours a day in front of their TVs, that's 5 hours of, if you're a content provider, you can start giving them your content. You can start introducing them to different content that they wouldn't have found otherwise. And plus, what about the other 19 hours of the day? Is there something that you can do that transforms their perception of what their TV is for, what it does? And plus, there's a whole load of statistics and various reports kind of saying that smart TVs, there's going to be massive growth in this market. Everyone's going to start having internet-enabled TVs. They're going to get used to the fact they're using apps on their TV, whether that be for content, whether that be for games, or something completely different. So one of the biggest differences that you're going to have as an Android developer is the UI, because you're no longer just sitting there with a touchscreen device. And one of the common misconceptions is when you're developing for TV, if you've got a tablet UI, that's going to fit perfectly on a TV. And that's not quite the case. When you're actually about 10 to 5 feet away, which most people are, you're actually going to, the perception you're getting of that screen is about the same as you holding a mobile phone at about arm's length. And I'm not saying don't use a tablet UI, that's fine, but you've got to be considerate of the fact that you're actually showing a lot of content on a tablet, and that far away you can't read text that small. It's not a nice experience. And plus, if you've got a news app and you have video content, promote that. It might not be the best thing that you want to put on a tablet. For TV, that's probably what the user wants to see. And I always like this diagram because it's a nice way of thinking about it. On a mobile phone, you can show so much information. Tablet, you obviously get much more real estate. You can show more. But when you get to TV, you start kind of tailing off how much you should be displaying to the user. So there's a couple of common things that you need to remember. One, you're no longer in that one-to-one device interaction. It's not one person playing with their device, no one else involved. You're in a social setting. People can be walking in, they can be walking out. So you have to start thinking, well, should I be worried about what I'm displaying on the screen? Does the user want me to be displaying this where someone else can see it? But then also, is there something that you can take advantage of? You're in a social setting. So the obvious example here is games. And it doesn't even need to be a multiplayer game. I've heard stories of people where greedy spiders, they didn't intend it to be a social activity, but the minute you start playing that with people around, they start screaming at each other. Do this, do that, no, kill it, kill it. So for them, it just happened. Secondly, who here's developed for the G1, Nexus 1, Magic? Yeah, there we go. You know with the trackball, you have to worry about the focus state, and it's exactly the same with TV. You need to do the focus state, because most people will use the D-pad, which means they need to know the focus state to work out where they are on the UI. If you don't do this, it becomes very, very difficult. So we obviously have a cursor. You can use a trackpad, but it's just not a nice experience for the user. If you ever get a chance to go play with a Sony box, it's not as nice to start using these devices just by using a cursor. It's just not nice. And you can see with the LG one, they've gone completely a different direction. They've gone for a Wii Remote style controller, so it works by accelerometers. And again, it's a nice solution to the problem, but at the same time, if you're trying to require them to hit a tiny little button, they've really got to kind of wiggle around and just about get it before they can actually hit it. And then when you start looking at your UI, you have to start thinking about whether you're worrying about selection state, where the user is within the entire app. Cyril kind of did this with his slide-in menu. And yeah, it's exactly the same with TV. Users need to know where they are in the whole context of the application. Like I said, you need to worry about the focus state. And then you can start using that. This is what we've done. We've started sitting there thinking, well, if we know exactly where the user is on the screen and they've hovered there for a little while, well, then they're probably interested. Show them more information. And this is a great way of fitting in with that information density. You're only showing it when they actually need it. In terms of designs, 720p and 1080p TVs are what we support. So they sit under the large bracket, and they're under the HDPI and, well, TV DPI and XH DPI. But generally, our recommendation is to go for HDPI and XH-DPI graphics. So one of the common UI design patterns that we're promoting is the left nav bar. So you may have noticed in this screenshot, there's kind of a missing UI design pattern that everyone in this room should be completely familiar with, which is the action bar. And we have our own version of it. It's on the left side. And the main reason behind this is because of D-pad interaction traps. If you imagine you had focus at the top of the action bar, you hit down on a D-pad, you enter in the list. And if you want to hit something down the bottom, you've got to scroll all the way through the list, get down the bottom, tap what you want, and then if you need to go back up the top, you've got to go all the way through the list. And that's assuming the list doesn't grow the minute you get to the bottom item. So you've got to start worrying about this kind of thing. And essentially what we're trying to do is move from this vertical kind of structure to more of a horizontal one. Because then that way you can scroll vertically as much as you want, you just hit left and right, and then you can start changing in and out of the zones that you want. And the way this kind of works is in the YouTube app, if you move from one side over to the left nav bar, it just expands out. And then that way you can learn some more information about what you're going to do, as well as start seeing the selected state. In terms of using it, all you have to do is call get left nav bar. You have to add in a library to use this, but essentially what this will do is it will just set it up for you. yeah, after that, it's essentially the action bar API. So it's no different to the action bar. We've ensured that it implements it. So this is a sample app that we've done because there's a load of extra settings. If you want to change the way it works in terms of you don't want it sliding in and out, you can do that. You can just have it out all the time or unexpanded. So yeah, check out this little link down the bottom because that has the library as well as this application so you can see what options you have to play with. And if you're doing one APK for tablets, phones, and TV, this is ridiculously useful. The dash television specifier. If you want to work out or do something specific for TV, just add dash television. You can change the layouts, change drawables, whatever you want. So the Anymote Protocol was used to fulfill the use case where developers have a mobile phone or a tablet app and they want to communicate with TV. So most of you will probably sit there and think, oh, okay, someone watching TV, someone like this, right? Mr. Leanback. So Mr. Leanback is about 45-degree angle, chilling out watching TV. But when you start looking at statistics, out of the people that own tablets and phones, most of them are going to be using them while they're watching TV. So they're not really fulfilled by just watching TV. They want to do extra stuff. So you can give them that. So from that, we have Miss Multiscreen. She's the ideal use case here. All the important things for TV. And then she might have a tablet somewhere out of shot, obviously, because she's going to have everything. Admittedly, this is an extreme, but you get the idea. If people have these kind of things, they can start playing around with them. And you can start engaging them with extra stuff that you can do with a TV that you wouldn't have been able to do before. So essentially, the Anymote Protocol is made up of a couple of different things. We have multicast DNS on the Google TV, which means if you start broadcasting on a local network, the TV will respond going, I'm here, these are the things that I can do. And then we have a pairing protocol, which is basically a communication between tablet and phone and the TV, which basically says, what challenges can I give you and what challenges will I be able to solve? And then once you've done that, you can basically pair, and then there's a secure connection between the two. And then after that, we have the Anymote Protocol, which basically means that you can start controlling what the TV is doing. So one of the problems that we had with this is we were basically saying, here's this protocol. It's protocol buffers. Just go, use it. It's awesome. A lot of developers went, well, I'm trying, but it's really not working. So we created the Anymote Library, and essentially what this does is just cut all of this out for you. It'll handle the discovery. It'll handle the pairing. And at the end, it will just go, here's this class, use this to communicate with the TV, and you're done. So this is what I'm going to be kind of talking about. So to start off with, you have the Anymote client listener. Now, all you have to do with this is kind of think of it as, while the life cycle is going on, where threads sitting in the background connecting to the TV, at the very end of this, it's going to go, here you go, here's the thing that you need to do all the communication, sending messages, etc. And all you need to do is just essentially say, from the UI, if an error or it gets disconnected, communicate to the user. Otherwise, just stash the Anymote sender, and that's all you need. The service connection, you just need this because when the service is obviously connecting, you just need to get the two lifecycle callbacks of connection or disconnected, and then you attach your listener at this point. So that's all nice and easy. The one gotcha here is, say you go from one activity to the next, the service is already running and it's already connected and it's going to stay alive. So when you have the service connection, just check if the Anymote sender is there. It's just a simple little method, get Anymote sender. And then that way, if it's already running, you can just pull it out at that point. You don't have to wait for the listener. And then you just call this intent. And all this will do, you don't have to do it in onCreate. You can do it whenever you want. You might offer it as an extra option saying, OK, if you have a Google TV, click this button, we'll connect to it, and we'll go from there. So what you can do with this is a whole multitude of things, but here's some of the extra classes that we thought some developers might like to use. So the touch handler, you pass it in any view along with the Anymote sender, and it will turn that view into a trackpad. So we have our open source remote control, and this is exactly what it uses. And it means that you can start controlling the cursor. But you also have some extra modes, so if you wanted to have scrolling horizontally or vertically, you can just lock it straight into that. Or you have zoom vertical, which I'm not sure how you developers use that one, but we've added it in. Sending key events. this is quite interesting. Any key that's on the remote control, you can send. So one of the use cases I've kind of had for this is if you wanted to change channel on a TV remote, well, you can just send a TV press, wait a little while, and then start sending numbers, which then changes the channel on the TV, which is a common use case if you're doing something like an EPG view. And yeah, I've included a little bit of info on those slides. I'll post these on my Google Plus and Twitter and stuff, so you don't have to worry about noting it down. But essentially, in the library, there's just a whole list of them that you can drag them out. And this is probably the most powerful one. Once you've connected, you can send intents from your phone to the TV. And they can be really generic ones. So you might want to launch a web page to launch in Chrome. But you might also, one of the common use cases is, if you're an app and you expect another app to be on the TV, then you can just launch it. So if you have a game, say poker, you've got a round of players all playing with their tablets and mobile devices. One of them opens up the app and go, OK, cool, connect to the Google TV. And then the first thing they do is just ping an intent to say, cool, open up the app if you're not already there. And the interesting thing with all of this is you don't necessarily have to be the app that's in the foreground on the TV. So if you imagine something like open intents, where you can basically find out all the intents from another app, and your app can essentially be a second screen experience for someone else's app, which is a bit of a weird one. So again, this is in the samples code. It's the same place as the left nav bar, but we've got a whole host of other libraries and samples in that. So I strongly recommend, if you do anything, that's the URL that you want to go check out. And I've kind of included this because even though we're saying, here's a library project, use this, it'll make everything easier, the discovery side of it, if that's all you're interested in, you just want to know whether there's a Google TV on the network, you can use JMDNS to just search for it. You can basically ping on the local network and see what comes back, and there's the Anymote service that you need to look for a Google TV, and you know it's there. You don't need to worry about anything else. If you wanted to do the pairing protocol, some people have customized the UI for this. So the challenge is always a hexadecimal code. So I've seen people who have done keyboards which are just 0 to 9, A to D, or F. And then the Anymote protocol, we've designed it to be platform agnostic, so you can port it to iOS or Chrome. I believe someone's already ported this to a C++ library to simplify all of this. So you're not bound to having to use this Android library that we've built. You can do it on other things. So yeah, we're using protocol buffers to make sure that all of this is device agnostic. We've got some extra APIs that are coming soon. So one of the ones that we're working on is custom streaming. We've had a couple of companies where they're content providers like SiriusXM, which is a streaming radio service. And basically what this does is means you can implement your own custom streaming, but you can do it in Java. You don't need to dive down into NDK. Custom DRM, again, content providers, they start rolling their own custom solutions to these kind of things, and normally they'd have to go to NDK. We've opened them up for the Java layer. And this is kind of the interesting one, which I'm surprised doesn't exist already, quality of service APIs. So the media player is very much closed down. You kind of play the video, and then that's all you can really do. We're opening it up so you can basically say, well, if I'm playing a video, am I buffering for 5 seconds, then playing 5 seconds, and then buffering for another 5? It's not a good user experience. So then, at that point, you should be able to go, look, I charged you for this. It's not working. You're getting kind of a really crappy experience, and I don't want to charge you for this. Or maybe try it again later on. You can at least then start handling this, as well as start using analytics to work out what your service is doing. And through this, we've actually added support for smooth streaming and Play DRM, or Play Ready DRM, using these 2 new APIs. So yeah, there's a great Google I/O talk from Christian Kurtzker. So if you are interested in any of that, strongly, strongly recommend you go check that out. And this one's a kind of a plug that I always get asked from YouTube to kind of give. They're announcing an Android Player API. Now, what this is you can embed YouTube videos inside your app. You don't need to ping out to YouTube anymore. So the way this works is you can either add a YouTube player view or a YouTube player fragment, and then from that you can start changing the UI all around it and do what you want with it. But essentially you no longer need to get kicked out of your app. You can start embedding it in. Supports monetized content and HD as well. So I'm going to include this because it may seem like I'm kind of just going, you guys are all developers, you know how to publish, it's fine. And you do. The problem is, a lot of developers, when they start going to TV, we've obviously done some things to ensure we don't just allow any app on the Google TV if it's not going to be supported, and if it's going to be a bit of a pants experience. So one of the big ones is don't force your app to work in portrait. The Android guys have been screaming this from the heavens, and basically one of a few things will happen. In the top one, if you just go activity, set in portrait, I'm not entirely sure whether we actually filter on this or not. I think we do, but I'm not 100%. The one below that, we definitely will filter on. You will not turn up in the search results. But the worst one you can do is the bottom one, where you do it in code and force it in portrait. Because what this means is you'll get through the filtering, you'll be allowed, providing you meet some other stuff, but then you will crash instantly, because Google TV doesn't support portrait because it's a TV in landscape. There's some of the features that we support. If you start adding additional features, please make sure that they're optional. They're not required if you don't need them, because essentially we will filter you out. It's stuff that we can't support, which means if you're saying you need them, it will crash when you reach that feature. So you need to just start being a bit more careful. If you start saying, well, I've done this, I've tested it, it works, I've uploaded it, why is it not showing up in the search results in Google Play? This could be the reason why. And finally, whatever you do, set touchscreen required to false. This is the main catch-all. Because essentially, every Android application, by default, you kind of require a touchscreen because every device has had a touchscreen. So it makes perfect sense. And if you only want to target Google TV, you don't want your app appearing anywhere else, then just set it required to have this library package, because this is only for Google TV, and that way you can just filter out on everything else. And finally, talk to us. If you produce an application and it's awesome and you're going to launch it, tell us, because we love hearing about these things. As well as that, if it's a great app, we'll put it forward for featuring and everything else. But you've got to tell us about it, because we love it. So the best place to get information is developers.google.com/TV. Loads of info there. The Google Plus link down there is probably where we're going to start announcing any new features and other stuff, and just keep you up to date with all the news. Other than that, that's kind of my talk. If you want to get hold of me, there's email, Twitter, G+, all that stuff. Otherwise, questions? Thank you.